Hello everyone, welcome to part 3 of the 4.5 notes, where we are solving logarithmic equations this time. We have just gotten done solving some exponential equations by using logs. Now we're going to solve some logarithmic expressions, or equations I mean to say, by using exponents. And so I'll explain more what I mean, especially getting into the next video, because we're going to solve, in this case, some simpler kinds of logarithmic equations first. Of course, we should always start with the simple ones. But remember, we had the equivalence property for the exponential expressions, where we could say if a to the x was equal to a to the y for the same base on these exponents, we could say that these exponents would be the same. This would mean that x is equal to y. That was the equivalence property for the exponential expressions. Here we have an equivalence property for logarithmic expressions that says that if you have the log base b of x on one side and this is equal to log base b of y on the other side, then that means that these two things, x and y, are equal. And so this will be in an ideal case where we have this kind of an equation. We can solve it by simply taking the arguments from the log and make them equal to each other. Otherwise, if we're not able to do it, we're in a little bit of a different situation, because if we're trying to solve for x, we need this x to not be inside of the log. We need it to be outside. But we're not able to just pull it outside the way that we did before with the exponential expressions, because this x is not in the exponent of something. It's just the base there. And so we will see how we can use this equivalence property to solve some logarithmic expressions. And then in the next video, we'll try solving some where it is not possible to use the equivalence property. We'll have to take a different approach. But anyways, let's get going with one of these. So you notice here for number 8, it's already set up so nicely for us. We have log base 2 of the quantity 5x minus 1 is equal to log base 2 of this other quantity 2x plus 17. Now since the bases on the logs are the same, they are both base 2, and we just have these two logs are equal to each other, then what we can say is that these ones, the 5x minus 1 and the 2x plus 17, those are equal to each other. And then we can solve for x just in the normal way. Of course, we can subtract, for example, 2x onto this side. It goes 3x minus 1 is equal to 17. We can add the 1. So 3x is equal to 18. And then when we divide by 3, we will get 18 over 3, which is, here x is equal to 6. And so those kinds of problems, they will work out very nicely. What about though if we have a kind of a problem like number 10? You notice here we don't just have two logs that are equal to each other. We have this difference of logs is equal to this log over here. We at least have the case where the bases are the same, because this kind of raw log over here, it means log base 10. And so all the bases are the same. But we really need this situation over here, that we just have one log is equal to another. We are able to use our property of logs to write the left side of this equation just with one log. And so remember, since it has a difference over here, it goes log minus log, then we're able to use the quotient property as the other one. So it goes log, and here we need to divide these arguments. It will go 3x minus 4 divided by x plus 1. Will be there is equal to log of 2. And now we are able to use that property, because it goes log of something equals log of something, so we can just set these arguments equal to each other. 3x minus 4 over x plus 1 is equal to 2. Now to solve for x in this case, we don't need to have x in the denominator here, so why don't we just multiply on both sides times this denominator. And then we're going 2 times that denominator, x plus 1. So we've just multiplied both sides times x plus 1. On the left side, x plus 1, it would just cancel with the denominator. And so we will have this thing that goes 3x minus 4 is equal to 2 times of x plus 1. Now the x is locked up in this parentheses. We need to distribute the 2 to get it out of there. So it will go 3x minus 4 is equal to 2x plus 2. Now we can subtract the 2x on both sides. And how about we will add the 4 as well. And so it will go on this side just x. The 4 will cancel, so we only have x on the left side. the 2x canceled over here, and it goes 2 plus 4, which is 6. So x was equal to 6 again. But anyways, that's how we will do these kinds of problems. We will just keep in mind all of these properties of of the logs that we've practiced in the 4.3, 4.4. They'll be coming back, and that's how we're going to be solving some of these equations. And so in the next video, we will see how to solve logarithmic equations that do not allow us to use this equivalence property. And I will catch you in that video. So thank you guys for watching, and I'll see you there.